Hello friends, this is Jim with Science Talk, and as you know, I've been covering a lot of the segments dealing with the permafrost, and so this is another report talking about the permafrost, but more so as what it could mean to people. We're well aware of the dangers posed to the thawing permafrost, as to the releasing of greenhouse gases into the atmosphere, further exacerbating a positive feedback loop. We know about what the retreating sea ice is doing for polar bears. We're seeing a northward migration of fauna and flora, and this will impact caribou that eat the lichen growing on the tundra, as more of the brushy willow brushes, for example, move further north. So all these are clear and present risks, dangers presented to the ecosystem, to humans. But now, something most of us have not considered: the ground underneath us, for those of us who live in the Arctic North. So what this report is going to be looking at is what's happening to the infrastructure. So this is a study that came out in the journal Nature Communications, and involves researchers from Finland, Norway, Russia, and the U.S., including my old institution there, IARC, International Arctic Research Center, as well as the Geophysical Institute at the University of Alaska Fairbanks, which is IARC and the GI, kind of they're next door to each other, basically. So what's happening now is the permafrost thaws. Well, a lot of what we do here, be it how we construct the roads, the buildings, railways, is predicated on the notion that we want to keep the ground frozen. We don't want it to thaw out. So we build up. You don't see too many basements, at least in interior Alaska, in home. Everything is built up off the ground. For example, my home, I put down what's called typar, which is kind of road cloth. It's basically looks like a weed kind of tarp. You brought in rocks on top of that, and you build up, and you can put the insulation in there to keep the ground cold. And I went post and pad on top of that. Airflow, because my building, I heat my building, so it gives off heat. So I want to have an airflow to sweep away any warmth that might make its way through my insulated floor. A lot of buildings are built like that. And the understanding is that the ground underneath there stays solid. In fact, if you look at the Trans-Alaska Pipeline, it's 800 miles long. About 400 miles is above ground, 400 miles is buried. Where it's cheaper to bury it, cost-wise, than to put it above ground. So where the pipeline is buried, the ground is either, especially in the southern portion of it, it's not frozen, so you can bury it directly. But if there is permafrost, it's in what's called permafrost that is what we say thaw stable, meaning that I've got a bunch of frozen rocks and pebbles, and when these frozen rocks and pebbles thaw out, I have a pile of rocks and pebbles. So we can put a pipeline in it. But the pipeline's hot. Yet there's an outer jackets, insulating, and all of that, but it's hot. The crude comes down at very high temperatures. So obviously that heat is going to go into the ground. Where the ground is permafrost, that's classified as thaw unstable, then we have to build up, because then the heat will cause what is termed liquefaction. In other words, you just make a big slurry out of the ground, and therefore the pipeline can start sinking, cracking, and cracks. That's obviously a problem. And so when you look at the way the Trans-Alaska Pipeline was built, for the sections above ground, there's all these big, huge pillars, steel pillars that are pounded as far into the ground as the engineers determined necessary for all the locations. And the pipeline itself sits on basically a steel platform, and it was designed so that it can slide back and forth to allow for seismic activities. Next to these pillars, you see these basically radiative fins. And the fins are filled basically with antifreeze. They work during the winter time, not the summertime. Because the summertime, the ground is still cold, colder, relative to the warmer air, so we want to keep the cold in the ground. During the winter time, when the air temperature is much, much colder than the ground temperature, we want to take any heat, the excess temperature in the ground, and dump it into the atmosphere. And basically, Alyeska, the company that oversees the pipeline, will fly helicopters up and down the pipeline with an infrared sensor, and the infrared sensor is looking at these fins to make sure they detect the heat plume. And when they don't, it says, oh, okay, they make a note of it and send a maintenance crew out there to rectify it. So, in essence, those cooling system is to dump heat out of the ground into the colder atmosphere during the wintertime months. So, but now what's happening as the ground starts thawing out? Well, then you start having stuff sink. Look at some of the old cabins that were built in the late 1800s, early 1900s, before they knew about such things. You put a wood stove in there, you fire it up, and what does what? It settles. The ground underneath starts thawing, and the building settles. You go up to the village of Wiseman, and you will see cabins where the top of the door is about a foot above the ground level because it has sunk in so far. You have to literally get a ladder to get back down into the inside of the cabin. Well, this is what's going to be coming to us as the permafrost continues to thaw. So we're looking at infrastructure collapse in essence for those in the far north. Right? Now, we know that the average worldwide temperature has increased by about 1.3 degrees Celsius over the last century plus. Well, the average warming of Alaska, let's take Alaska as an example, over the past 4 decades, 40 years, been about 4 degrees C. That is significant. All the permafrost south of the Yukon River is very close, about within less than 1 degree Celsius of completely thawing out. A lot of it is already thawing out. The rest is very close to thawing out. And as I said, this is going to impact infrastructure. So, these researchers, as they reported in the journal Nature Communications, they examine, the infrastructure of what they call the permafrost world region. And of course, permafrost is ground that's defined as frozen solid for at least 2 consecutive years. Now, that's notwithstanding any seasonal thaw layer that typically is within the upper 1 meter at most. Typically it's really about 30 centimeters typically. You get that little upper thaw, the little layer. It can thaw out a little bit in like July, and then refreezes back up by the time September rolls around. More than 4 million people live in this pan-Arctic landscape. 3.6 million of them, 70% of their transportation and industrial infrastructure are at risk. So, Professor Vladimir Romanovsky, who is of the University of Alaska Geophysical Institute, nice gentleman, I know him, these observations have led me to believe that global warming is not a fake, this is a direct quote from him, but the reality. And here in Alaska, we are dealing already and will be dealing even more in the near future with this reality. Climate scientists, glaciologists have been warning about the rate of change. How many times have you heard me emphasize the concept of the rate of change that is the critical concept in all of this? And they've been warning about this rate of change in the Arctic for 2 decades. Here's an interesting statistic. For every 1 degree Celsius of warming, around 4 million square kilometers of permafrost, which is an area bigger than India, could thaw. And of course, we know that in the permafrost is all the organic material, and then they stop thawing, and then we have the release of methane and carbon dioxide. But, and one of the big problems, one of the big questions, and gentlemen such as Igor Semeletov, also of IARC, he and his wife Natalia have been doing stellar work examining the carbon issue in the permafrost. They're trying to estimate just how much is there and what's the rate at which it's being released into the atmosphere. Well, current estimates now are at 1.700 billion tons, 1,700 billion tons of carbon. 1,700 billion tons of carbon, with a B. This is about twice the mass of carbon in the atmosphere. And of course, this is in the form of greenhouse gases like CO2 and CH4. Its release could precipitate even more calamitous climate change. And of course, now it goes along with that, any economic consequences, which is assessed currently at an estimated cost, potential cost, of 43 trillion, with a T, dollars. 1,700 billion tons, about twice the mass of carbon in the atmosphere. That is a load. Because if this gets released slowly, it'll be bad enough. If it gets released a lot all of a sudden, aerobic life is probably screwed on this planet, at least for terrestrial. And then that will mix with the water, and you get the acidification of the oceans that we have discussed numerous times before. So this latest study, and it's really interesting, 1/3 of all Arctic infrastructure, 45% of hydrocarbon extraction fields in the Russian Arctic were in high hazard regions. Once the soil thaws, the ground becomes unstable. In other words, these are places found in ground that is identified as thaw unstable. Basically, it's frozen loess, which is soil. And when that thaws out, it just turns into basically a big mudslide, a liquefaction, as I said earlier. So here's some, don't forget, Russia, it covers 11 time zones. It's the largest country on the planet. And a lot of it is up in the high latitude regions. So around 470 kilometers of the Qinghai-Tibet Railway and 280 kilometers of the Obskaya-Bovenenkova Railway. Okay. These are the most northerly railways in the world, and they basically go right across this thawing permafrost. So now you could have these rail systems, and you add it together, and we're talking about what, 750 kilometers total of a rail line that's at risk. Scientists identified more than 1,200 settlements in zones where the permafrost could thaw around, and around 40 of these had populations of 5,000 or more. So 1,200 settlements where the permafrost could thaw literally from out underneath their feet, and 40 of these had populations of 5,000 people or more. We're seeing in Alaska, permafrost is thawing, but with the lack of sea ice forming, there's more open water, so there's more coastal storms battering the coast. This is causing massive, because the ground is now thawing out, so now the wave action, massive chunks of coastline is dropping into the sea. There have been several villages that have had to relocate further inland because they're literally losing the land right out from under them. So as I said, if you guys want to look this up to see it on the map, these railways, Qinghai-Tibet Railway, it's Qinghai, Tibet, and then the Obskaya-Bovenenkova Railway. Big Russian word there, but It, you can go look those up there and see where their roots are. It's that can be bad because the railways bring critical supplies, sort of like, you know, trucking things in. So if something happens to these railways, there's a problem for these people getting necessary supplies in. Pipelines are also endangered. Close to 1,600 kilometers of the Eastern Siberia Pacific Ocean oil pipeline is in danger. 1,260 kilometers of the gas pipelines in the Yamal-Nenets region, which supplies 1/3 of European Union imports. 550 kilometers of the Trans-Alaska Pipeline is also a considerable risk. And I described for you at the onset of this video segment about the pipeline. Basically, any section where the pipeline is going over thaw unstable permafrost is at risk, and that's true for all of these. And a lot of these pipelines are in areas where near surface permafrost could thaw by 2050. By then, around 1 million people, 36,000 buildings, 1,300 kilometers of roads, 100 airports could have become high hazard environments. And with them, permafrost thaw could threaten to affect 45% of oil and gas fields in the Russian Arctic, as mentioned before. So a lot of things are at risk. And you know, this is looking at like Russia, Arctic, and Alaska. Go over to the Canadian side, Nunavut, right? Northwest Territories, Yukon Territories. There's communities there that are affected. You know, there is a gas pipeline that comes down from the Mackenzie Delta. In fact, there's been talk of going from that gas field or to take the gas from the north slope of Alaska, like the Prudhoe Bay area, move it east to hook up with that gas pipeline out of the Mackenzie Delta to bring it down south of Market. So you have that gas pipeline that's also in danger. There's a gas pipeline that runs from the north slope of Alaska down to Pump Station 4, which is just north of Vatican Pass. That is also in danger, and that's a 6-inch pipeline. And that supplies the power to, like, the, you know, some of the pipeline, the pump stations that are along there. Now, the authors do concede that these forecasts do carry large uncertainties, big errors associated with them. They could be wrong, but they warn that even if they are, their estimates of the infrastructure at risk would probably not be much smaller and could be substantially higher. So I think, just as I've described for you guys before, the only way, in my opinion, really, the only way you're going to get politicians to actually act is when they start seeing economic issues. You have to put a dollar sign on things. Just from the scientific aspect, the moral aspect, it's, you know, the quote unquote right thing to do. They don't do squat. Start waving dollar signs in front of them. Start saying that, you know, this is going to cause economic damage. Then they'll probably get their butts in gear, but it might be too late when they do. So anyway, I wanted to bring that report, kind of where this is now starting to drive home what we're doing, that we're now starting to impact our own infrastructure. So, until next time, thank you for your time. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. We need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.